Okay, so we've already done graphs of both sine and cosine. So today we're going to look at the other four trig function graphs, which are tangent, cotangent, cosecant, and secant. So we're going to start with tangent because it's kind of its own trig function. Then after that, everything we can look at, we can think about in terms of a reciprocal. So if I go back to the way we found our graphs of sine and cosine, if you'll remember, we went around the unit circle and we found a bunch of different values. We went, the first day we did sine, we found all the way, what was it when I rotated pi over 6 radians, pi over 4 radians, pi over 3 radians. And we found all those points and we graphed the curve. We're not going to spend as much time with tangent and cotangent, but no, you could find those the exact same way. You could go through each point on our unit circle, the ones that we have memorized or know how to find using special right triangles, and we could find out all of these values or some approximation of them. So, what we do need to know is that tangent of any angle is equal to y over x. So on that unit circle, we think about the ratio of the y value to the x value. Remember, sine is equal to the y value, cosine is equal to the x value, tangent is y over x. So if I think about rotating, so instead of actually finding every point, we're just going to think about what happens when we rotate. So when I start off here with a 0-degree rotation, okay, well this is the point 1, 0. So if I think about plugging that in here, that would be 0 over 1, which is 0, which means at the x value of 0, the y value should be 0, which it is right here. And then let's think about what happens as we rotate along that unit circle. So initially, my x values are going to be really close to 1. So the numbers on bottom are going to be really close to 1. The numbers on top are going to be really close to 0 when I first start. So this is going to be a really small number divided by something bigger than it. So you get values that are less than 1. So you see how the graph kind of starts off very slowly. Okay, then you're going to get the point right here where the x value and the y value are the same, which happens at a 45-degree rotation, or pi over 4. And at that point, when my x value is 1, my y value should also be 1. Okay, so that's happening right there. The reason it's not lined up exactly is because these x values are not going by 1, 2, 3. If you'll remember, we like our x values to be in terms of pi's. So this would be pi over 2. This would be pi. This would be 3 pi over 2. And the last point here would be 2 pi. So when I get to right here, this is when I've rotated all the way up to a 90-degree rotation. So as I get closer and closer, my y values are getting larger and larger, and my x value is getting closer and closer to 0. So like say this point right here is maybe 0.1 and 0.9. So when you think about plugging that in, 0.9 divided by 0.1, that's going to be 90. So when I get really close to pi over 2, my y values are getting huge. Okay, because I'm just finding those by doing this division. So this is getting larger and larger all the way up to infinity or approaching infinity. It can't get to infinity. But then what happens here? Well, when I get to a 90-degree rotation or a pi over 2 rotation, if I think about this as being y over x and plugging it in, I get 1 over 0, which is undefined. So in that homework, we had different rotations that gave us undefined values. When I get something that is undefined, that is going to be represented by a vertical asymptote on my graph. So you can see as I get closer and closer to pi over 2, the graph approaches infinity. It gets huge. And then as soon as we pass it, Now you're going to have a negative x value. So my y value is going to be still close to 1, but my x value is going to be negative. So instead of approaching infinity just past pi over 2, it's going to be at negative infinity. So the graph essentially starts its pattern back over. And that continues on and on as you keep approaching them. So as you get to here, at a rotation of pi, you're back to 0. As you get to 3 pi over 2, you're back to 1 over 0, which is going to be another vertical asymptote. And so you can see as we graph them, we have a bunch of, it looks like cube functions where you have those snakes, and then you have vertical asymptotes that go with it. So again, you don't necessarily have to know how to find it, but I always think it's good to kind of see where it comes from. When we graph them, we're going to use critical points. So this is one that's kind of odd to work with because your critical points are not that great. When my x value is 0, the y value is 0. That's the first critical point. Okay, then my next critical point is at pi over 2. When I get to pi over 2, I've got a vertical asymptote. So that's not really a point, but I still like to think of it as a point because it makes it easy to move those asymptotes around. Next is when I get to pi, I'm back at 0. 3 pi over 2 is another vertical asymptote, and 2 pi is 0. So really what you have to remember are these critical points and that tangent as it goes along increases. So think about between these asymptotes. So between an asymptote here and here, tangent is increasing. It starts off really close to negative infinity, and as I go left to right, it gets bigger and bigger. As it approaches the x-axis, it snakes, and then it's going to snake through and get closer and closer to positive infinity until we get to the next asymptote. And the reason you have to remember that is because if you look at cotangent, what does cotangent do? It does the opposite. Cotangent decreases and then hits an asymptote. Decreases, asymptote, decreases, asymptote. So you're going to have to remember the difference without having the benefit of those points to guide you. Okay, as I look at cotangent, well look, at tangent, at 0 we got the point 0. Well, what happens with cotangent? At 0 we have an asymptote. Because what is cotangent? It's just the reciprocal of tangent. So with tangent we got 0 over 1, which means with cotangent we will get 1 over 0, which will in turn give an asymptote. So when I think of my critical points for cotangent, they are 0 vertical asymptote. Pi over 2 is going to be 0. Pi is going to be a vertical asymptote. 3 pi over 2 will be at 0. And 2 pi gives a vertical asymptote. Now before we move off of tangent and cotangent, there is something that is unique with tangent and cotangent that is unlike the other trig functions. So if you'll think back to all of our different characteristics of graphs, we looked at amplitude. Okay, amplitude with sine and cosine was what it oscillated between. What was the low value and the high value? When we look at tangent, its amplitude, we can't really talk about it. It's from negative infinity to positive infinity. Phase shifts, which go left to right, we can still have phase shift changes. Going back to the amplitude, if we have a number out front that's multiplying it, it works kind of like a stretch or a compression. If we stretch the graph, then that means it's going to make the snake happen quicker. Right? Think about if you pulled that on both ends and stretched it. Right? It's going to be more dramatic here at the snake. and then if I compress it, then it's a slower snake. I'll get up here and I'll go very sideways. Phase shifts work the same. Shifting up or down, vertical shifts work the same. And then period change. That's the one I wanted to talk about with tangent and cotangent. So period is how long did it take for the graph to repeat itself. So with sine, if you'll remember, we start off here at the origin. The graph goes up, it goes down, and then it comes back to complete one cycle. So the period of sine and cosine was 2 pi. If you look at tangent, how long does it take tangent to repeat itself? Okay, well, it goes up, and then it's down here, and it reaches back to the origin again, and it goes up, and it's here. So is its period 2 pi? No, it's repeating itself quicker than sine and cosine did. So for tangent and cotangent, the default period of those is just pi radians. And another way you can think about that is think about what happens with our little rule for all students take calculus. So if I think about sine, sine is positive, positive, negative, negative. Positive, positive, negative, negative. You have to get all the way around the unit circle before the pattern repeats. Positive, positive, negative, negative. Positive, positive, negative, negative. If you think about cosine, cosine goes positive, negative, negative, positive, positive, negative, negative, positive. So I have to get all the way around before it repeats. You see what I'm talking about? The pattern. Well, what happens with tangent? Positive, negative, positive, negative, positive, negative, positive, negative. It repeats its pattern quicker than sine and cosine do. That also is an explanation to kind of help you understand why the period is pi instead of being 2 pi. People forget that all the time. So there you go. Now the next one's cosecant and secant. Okay, those are just reciprocals of sine and cosine respectively. So when I think of cosecant, I'm thinking that's the reciprocal of sine. So you can see they've already graphed our sine wave for us right here. This is the sine wave. Okay, so the cosecant graph is all these parabolas around it. That is the cosecant graph. So where does that come from? Well, think about the reciprocal of numbers. So, like, for instance, if my if my y value used to be a half, the reciprocal of 1/2 is 2. If it used to be a third, the reciprocal is 3. A fourth is 4. If the y value was a fifth, it would be 5. If the y value was 1 over 1,000, then the reciprocal would be 1,000 over 1. So while the while the sine and cosine graphs oscillate between 1 and -1, cosecant and secant can't get between 1 and -1. They get all the way down to a low value of 1, but then they go to infinity. And then down here when they're negative, they reach a value of -1, but they go to infinity. It's just the reciprocal of each one of these waves. And you can see secant is similar. So this is my cosine graph, and the graphs are the reciprocals here. So again, when I think about my critical points, so again, these graphs have asymptotes. Where sine used to be 0, now I'm going to have an asymptote. And then in the secant graph, where cosine used to be 0, I'm going to have an asymptote. And then I have parabolas around them. So as I think about my critical points for cosecant, at 0, I have a vertical asymptote. At pi over 2, the value is 1. At pi, I have a vertical asymptote. At 3 pi over 2, my value is -1. And at 2 pi, I get another vertical asymptote. So again, cosecant is the reciprocal of sine. So if you think about your sine points, everywhere you used to have a 0 is now a vertical asymptote. Because when you flip sine, or when you flip 0, you get 1 over 0. And then what happened? When I used to have 1 and -1, there's still 1 and -1. Because their reciprocal is the same value. And so you can see that's where my graphs meet. And then you just have to know cosecants are parabolas in between those vertical asymptotes. So again, what people get confused on, cosecant does not cross the x-axis on its normal graph before we do any transformations. So if I started here at +1, then that graph is going to stay above the x-axis. If I went and started at -1, then I know that that parabola will be below the x-axis. And then secant, again, just listen to the critical points. I've got 0 and 1. At pi over 2 is now a vertical asymptote. At pi, I will have a value of -1. 3 pi over 2 will be a vertical asymptote. And 2 pi will again be a value of 1. Okay, so right here it tells me to find the period, sketch at least one cycle of the function, and state the range. So I've got y equals tangent of 4x. So my original function would be tangent. And so I'm thinking, what are my critical points for tangent? Okay, well, tangent starts at 0, 0. Then at pi over 2, we have a vertical asymptote. At pi, we're back to 0. At 3 pi over 2, we have a vertical asymptote. And then at 2 pi, we're again back to 0. Okay, so the first thing it tells me to do is find the period. So by default, tangent's period is pi radians. So to find the new period, we're going to take the default period and divide by this number being multiplied on the inside, just like we did with sine and cosine. So my new period is going to be pi over 4. So now I took my original period and divided by 4. So now I'm going to divide all of these x values by 4. So when I divide 0 by 4, it's going to still be at 0. So I'm trying to find a good way to do this. I kind of ran out of room. So this is going to still be 0. When I divide this by 4, it's going to give me pi over 8 vertical asymptote. When I divide this by 4, it's going to give pi over 4, 0. When I divide this one by 4, it's going to give me 3 pi over 8. And that's going to be a vertical asymptote. And then right here, 2 pi divided by 4 would give me pi over 2. And it's going to give a value of 0. So now when I make this graph, okay, my x values are going up by pi over 4 every time. So right here is going to be 0, 0. So I'm going to draw a tick mark here. I'm going to make this pi over 4. Try to evenly space them. So this is not pi over 4, is it? Pi over 8. Sorry. This will be pi over 8. The next one would be 2 pi over 8, which is pi over 4. The next one would be 3 pi over 8, 4 pi over 8, which is pi over 2. Okay, we can stop there. So I've got at 0, the point 0, at pi over 8, I now have a vertical asymptote. At pi over 4, I've got the point 0. At 3 pi over 8, I now have a vertical asymptote. At pi over 2, I've got the point 0. And so, like I said, you're not going to be given as much graph here to work with because my critical points are not as revealing. So you're going to have to remember, because this is tangent, the graph should be increasing between the asymptotes. So I'm snaking between them. And I'm crossing the x-axis halfway through each one of them. So when I'm looking at the graph, I'm looking, okay, did they put the asymptotes in the correct spot, and did it snake going in the correct direction? And then did they cross the x-axis near where they're supposed to? Now the last thing it does is it tells me to identify the range. So the range is the y values. So the lowest y value the graph takes on is negative infinity, and it goes all the way up to positive infinity, and it takes on every value between them. Right? There's no gaps in the graph. It goes all the way from negative infinity to positive infinity. Okay, the next one is 2 plus cotangent of x. So I could think about that being the same thing as cotangent of x plus 2. So this is just a vertical shift where we're shifting the graph up 2. So with cotangent, my critical points are 0, asymptote, pi over 2, 0, pi, asymptote, 3 pi over 2, 0, and 2 pi, asymptote. And now we talked about the only transformation here from my original is this plus 2. So even though it's in the front, it's the same as it being in the back. Adding 2 doesn't care if it's in the front or behind. So that's a vertical shift up 2. So I'm going to add 2 to all of my y values. So when you add 2 to an asymptote, nothing happens. It's still an asymptote. But right here, it's going to change where the snake part happens. So now instead of happening at pi over 2, 0, it's going to happen at pi over 2, 2. And here, instead of happening at 3 pi over 2, 0, it's going to happen at 3 pi over 2, 2. So those are the only points that change because asymptotes do not change. So now when I think about graphing that, I need to get my x values. So I'm just going to mark them off with what my x's are increasing by. So this is still pi over 2, pi. Let me move my graph over. Here we go. 3 pi over 2 and 2 pi. And now, like we said, where the snake part happens is now moved up to 2. So I have the points at 0 is going to be a vertical asymptote. At pi over 2, it should snake at 2. At pi, we've got a vertical asymptote. At 3 pi over 2, we've got a value of 2. And then at 2 pi, vertical asymptote. Now this was a default cotangent. So cotangent decreases between the asymptotes. So now when I graph this, I'm going to do it in blue. My graph starts up here. It's going to snake through that point. That's where the snake part happens. Right? And then it continues down for cotangent. So same thing here, snake through that point. So what's happened is it's taken my original cotangent, which normally snakes through the x-axis, and it's moved it up. Whether it's cotangent or tangent. If it's tangent, like we had here, the snakes have to go increasing. When it's cotangent, they are decreasing from left to right. unless we get a reflection, which could happen. That's just by default which way they go. Okay, the next one here is -3 cosecant of x. So cosecant is the reciprocal of sine. So I know sine starts at 0, 0, which means this one's going to start at 0 vertical asymptote. Okay, then at pi over 2, sine goes up, so this one's also going to go up to 1. Back to pi, 0 will be a vertical asymptote. 3 pi over 2 will go down to -1. And then 2 pi will be a vertical asymptote. Now what's happened here, we've got an amplitude change, so we've got a stretch by 3, and then we also have a reflection, which is going to change the sign of each one of those y values. So again, those do not affect an asymptote because they're just somewhere the graph can't go anyways. So if I stretch an asymptote and reflect an asymptote, nothing changes. But these points here at 1 and -1 will be changed. So remember, on the outside, that affects the y's. So we could think about multiplying these y's by -3. So now instead of being pi over 2, 1, it's going to be pi over 2, -3. And instead of being 3 pi over 2, -1, that's going to be 3 pi over 2, +3. So now when I'm making my graph, make the x values, this is pi over 2, pi, 3 pi over 2, and 2 pi. At 0, we're going to have a vertical asymptote. That was pretty bad. That's better. Okay, then at pi over 2, we need a value of -3. So I need to count down -1, -2, -3. So I've got pi over 2, -3. At pi, I have another vertical asymptote. At 3 pi over 2, I have a y value of 3. So I need to count up 1, 2, 3, which would be here. And then at 2 pi, I have another vertical asymptote. Okay, and then secant and cosecant, they are parabolas between those asymptotes. So my graph would look like that there in the green. And like I said, we could continue this pattern throughout if you want to do another one over here. And then another one down here. Between those asymptotes. I realized on the last one I didn't give all the answers. So I'm going to go back to 2 here. Okay, it asked for the period. Well, it was cotangent, so the default period is pi. And then we did not change the x's, so the period would still be pi. And then when I look at the range, okay, well, the lowest y value it takes on is -infinity, and it goes all the way up to +infinity. There's no gaps between them. So the range here would be from -infinity to +infinity. Now when I look at cosecant, I have to first state the period. So the normal period for cosecant is 2 pi, and we did not change that. So it's still 2 pi. Okay, now when I state the range, okay, well, the lowest y value the graph takes on is -infinity, and then it goes up to -3. And then there's a huge gap until the graph goes again at positive 3, and it goes up to positive infinity. So this in between is not part of the range. So when I state the range for this graph, it would be from negative infinity to negative 3, and that's included in a brace. And then I would need to union, and the graph starts back again at 3 up to positive infinity in parentheses because infinities aren't included. Okay, so here's the next, or the last one, y equals secant of x minus pi over 4. So this time we have a phase shift that's happened. Secant is the reciprocal of cosine. So I know for cosine, my critical points are at, the first one's at 0, 1, so secant will still be 0, 1. Pi over 2 for cosine is 0, so that'll be an asymptote. Pi is at negative 1, so it'll still be negative 1. 3 pi over 2 is normally at 0, so it's going to be a vertical asymptote. And 2 pi gets us back to 1, so it's still 1. Now this time I have a phase shift of pi over 4, which means I need to add pi over 4 to all of my x values. So now this is going to become pi over 4, 1. When I add pi over 4 here, that's going to be 3 pi over 4, vertical asymptote. Add pi over 4, so that's 5 pi over 4, negative 1. This becomes 7 pi over 4, vertical asymptote. And 9 pi over 4, 1. Okay, so this is normally the hardest one for people to make their own graphs because you just want to put pi over 4 and then put 3 pi over 4. Okay, but that's not going to be how these work because I shifted right. That's not an equal gap from here to pi over 4 and then pi over 4 to 3 pi over 4. So what I would do is I would put my first tick mark here as pi over 4. And then when you evenly space them, you're going to have to skip 1, and then the next one will be 3 pi over 4. This is pi over 4. This is 2 pi over 4, then 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Okay, so when I graph those, pi over 4, 1. I don't need to do green. That's going to blend in with the last one. Let's do red. So pi over 4, 1 is here. 3 pi over 4 is a vertical asymptote. 5 pi over 4 is at negative 1. 7 pi over 4 is a vertical asymptote. And then 9 pi over 4 is back at 1. It's parabolas. So that would be one full cycle. If you want to continue it, your asymptote would be somewhere there. You would be down here. Asymptote. You can tell I'm a very neat person, huh?
Why did you skip that in between?
To keep them evenly spaced. So, like right here, we were going up by halves. So this is 1 half, 2 halves, 3 halves, 4 halves, and so on. On the one above it, again, by halves. Right here, I was going up by 8ths, but I was going up by 8ths equally. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. The problem here is, if I say from here to here is a 4th, then I can't do the same distance and say that this is all the way to 3 pi over 4. You have to evenly space them, just how like a ruler. So if this is pi over 4, then the next one has to be plus another pi over 4, which puts me at 2 pi over 4, which is not a point that I need.
Does it matter what size your parabolas are? 'Cause mine are like 10.
No. I'm not going to, no. I'm going to look, and this is what I'm looking for. Did the point happen here where it's supposed to? And then is it facing the correct direction?
I just didn't know if like the rest of it was supposed
Okay, then for this last one, let's give the period and the range. So the period was 2 pi, and there was nothing given to change that. We didn't multiply by anything on the inside, so it's still 2 pi. The range, though, so it has negative infinity values. It keeps getting more and more negative. It approaches all the way up to -1, and then there's a gap. So my range goes from negative infinity until -1, union. Then it picks back up at +1 up to positive infinity.